All right, the first problem on your test, find the absolute extreme values of the function f of x equals 6 plus 12x minus x cubed on the interval from -3 to 3. When they give us a closed interval, they're asking us for the absolute extremes, which means the max, absolute min, which means the absolutely highest and absolutely lowest values. So the easiest way to do this is just to find the first derivative, which is going to be 12 minus 3x squared. And we have a polynomial function. The three criteria for critical numbers are endpoints. So my critical numbers will be -3 and 3. Anywhere the derivative equals 0, so if I set the derivative equal to 0, I get 12 equals 3x squared, which gets me 4 equal to x squared, which means x equals plus or minus 2. Be careful, if you got x squared equals number, get the positive and negative square root. As long as these numbers are within this interval, they count, and both these numbers, 2 and -2, do lie in that interval, so -2 and +2. The other criteria for critical numbers would be anywhere the derivative is undefined. Polynomials aren't undefined, so that's irrelevant. So these are the only critical numbers of the problem. So now if I evaluate f of -3, f of +3, f of -2, and f of +2, notice they're f of, so we're going back to the function itself, evaluate it. So I go to y equals, I enter 6 plus 12x minus x to the third. Go to my table, and I enter -3, 3, -2, 2. We get f of -3 is -3, f of 3 is +15, f of -2 is -10, and f of 2 is +22. Again, they're asking us for the absolute extreme value, so the absolutely largest number here is this one. So absolute maximum of 22 at x equals 2, absolute minimum of -10 at x equals -2. And that will be the absolute extreme values. Again, I'm looking for the value and at what x value it occurred, and that's kind of how I want the answer to be written. Number 2, same deal. This time we have a trig function instead of a polynomial function, but it's the same idea. Absolute extreme values, they occur at the critical numbers, and critical numbers will be 0 and pi for sure. Beyond that, I have to do the derivative. So f prime of x is going to equal 3 minus sine of x minus 3 cosine of x minus cosine of 2x. And since that's sine of 2x, cosine of 2x, derivative of sine, but then times 2, the derivative of 2x, I have to do the chain rule for that one piece there. Looking at that, it doesn't look very easily solved. I can obviously see that it's not going to be undefined because sine and cosine are never undefined. But to set it equal to 0 would be somewhat challenging. So I would probably go to y equals here, and 3 minus sine x minus 3 cosine x minus, and I'm going to type in 2 cosine of 2x. My window I'm going to set from 0 to pi because we only care about numbers that happen on the interval itself. A scale of 1, that just means h dash is 1. It might help me guess better. We're looking for where it equals 0. Equals 0 is what we're looking for there. So if I just set the calculator's y values, let's say -2 to 2 would be sufficient to see where the zeros occur. Hit graph. Where it crosses the x-axis is what matters. And I'm noticing as it's trying to graph it, it's in degrees, not radians. I'm going to have to change it. There's a way to just stop it while it's graphing. So, go to mode, make sure we're in radians, not degrees. I'll try graphing again now. There we go. So across is about 0.7 or something like that. Can't tell exactly where, but we'll get that in a minute. And still thinking. Oh, that's it. So it's done thinking. That's the entire graph. Obviously it started below and ended up here somewhere and never came back down. The only answer here is between 0 and 1. So if I hit calculate, I'm trying to find the 0, so 2. I'm going to go left bound 0, right bound 1. I'm going to guess 0.7. and we get 0.75. If I actually want a couple more decimal places, there's 7534. We're not actually graphing it, we're trying to find the minimum, or min or max, so getting a few extra decimal places isn't going to hurt. So my critical numbers are here. Again, endpoint, derivative equals 0, and again, derivatives never undefined, so those are all the critical numbers. I'm going to evaluate f of 0, f of pi, and f of 0.7534. Right, so if I go to y equals again, type in the original problem, which is 3x plus cosine of x minus 3 sine of x minus sine of 2x, I believe. Yep, sine of 2x. And go to my table, enter those three values in, 0, pi, and 0.7534. We get 1, 8.4248, and negative 0.0608. So obviously 8.4248 is the largest, negative 0.0608 is the smallest, so absolute max of 8.4248 at x equals pi, absolute min of negative 0.0608 at x equals 0.7534. So the first two problems on the test will be absolute extreme values. Find a derivative, find the critical numbers, evaluate the function at each of the critical numbers. The biggest is the max, the smallest is the min. Anything in between is not going to be relevant for that question. Number 3, an infinite limit. When it's written as a rational structure like this, we want to find the highest power of x that occurs. And on the bottom, it's the first power. On the top, it's also the first power because this is a square root. Just ignore the fact that there's multiple terms. Highest power divided by the root. So 2 divided by 2 is 1. So altogether, the highest power in the entire problem is 1. That's what you have to multiply by 1 over that thing. So I'm going to multiply by 1 over x on the bottom. I'm going to multiply by the square root of 1 over x squared on top. And keep in mind, when we have to do a square root, we want to look and see what x is approaching. X is approaching a positive infinity, so this is a positive thing. This is also positive as well. If this were approaching negative infinity, this would be negative. This would still be positive, so you have to put a minus sign. So we watchful for that possibility. And again, I'm multiplying it as a radical structure because that's what kind of structure I have on top. So I'm going to get limit as x is approaching infinity of the square root of 3 minus 10 over x plus 1 over x squared. So inside the radical, everything's being multiplied by 1 over x squared. 10x times 1 over x squared, 1 of the x's cancel. 1 times 1 over x squared, nothing cancels. 1 over x squared times that, the x squared is canceled, leaving 3. On the bottom, 1 over x times 2 is just 2. 1 over x times 7 is going to be plus 7 over x. As we approach infinity, any number divided by x or x squared is going to go to 0. So we end up with, on top, the square root of 3 minus 0 plus 0. On the bottom, we get 2 plus 0. So once we've created this structure where every object's been multiplied by 1 over the highest power of x, we create a situation where we can substitute the infinity in. All these zeros just go away, so I end up with the square root of 3 over 2 as the limit. For number 4, again, an infinite limit. If I put infinity in here, I'm going to get infinity. Infinity here, I get infinity. That's infinity minus infinity, which is indeterminate. So I got to come up with a technique for doing this. When you're subtracting infinities, the best way to handle this situation is to multiply top and bottom by the conjugate of the top to create a fractional structure, because just like the last problem was, a fractional structure is easy to work with. So I'm going to multiply the top by the square root of 2x squared minus 3x minus 1 plus the square root of 2x squared plus 3x plus 1. We do the same to the bottom. And that gets me on top, so I'm going to still have a limit as x approaches infinity. But now we're going to get this nice fraction here. On top, I've got a difference times the sum of the same things, so that's just a difference of squares factored form. So this times itself just makes 2x squared minus 3x minus 1. And this times itself makes minus 2x squared plus 3x plus 1. And all that goes over our square root of, oops, too long of a square root sign there. Square root of 2x squared minus 3x minus 1 plus the square root of 2x squared plus 3x plus 1. So now, notice it is minus and it's multiple terms. Be careful those parentheses go there, so we distribute a minus sign all the way through that. Everything on top is just polynomial structure, so I can just do some simplification here. 2x squared minus 2x squared cancels. Negative 3x minus 3x is negative 6x. Negative 1 minus 1 is negative 2. On the bottom we have this square root of 2x squared minus 3x minus 1 plus the square root of 2x squared plus 3x plus 1. At this point we have a similar structure to what we had on the last problem, where we have a rational structure, simplified rational structure, and I'm going to find the highest power of x in the entire problem. X to the first, x to the first, x to the first. So again, inside the radical, squared divided by 2 is first. So altogether the highest power is the first power. So multiply top by 1 over x, bottom by 1 over x. But again, on the bottom it's going to be the square root of 1 over x squared, since I'm multiplying by square roots. That gets me limit as x is approaching 0, or sorry, infinity, of negative 6 minus 2 over x over the square root of 2 minus 3 over x minus 1 over x squared plus the square root of 2 plus 3 over x plus 1 over x squared. And at this point we've created whole number structures, or integers at least, and then numbers over x. So as x approaches infinity, each of these guys here and here and here and here and here all go to 0. All the others just stick around. So if I put infinity in on top, I get negative 6 minus 0. On the bottom I get the square root of 2 minus 0 plus the square root of 2 plus 0 plus 0. So altogether what that ends up giving me on top is negative 6. On the bottom, square root of 2 plus square root of 2 makes 2 times the square root of 2. So negative 3 over the square root of 2, which if I rationalize the denominator gets me negative 3 times the square root of 2 over 2. So that will be the approximate value of this as x approaches infinity. So that's how I'm looking for you to do it. Again, on the test, you should expect a radical minus a radical like that, creating those infinities. There's no way to really simplify that structure, so to create this rational function with a polynomial numerator and radical denominators makes it workable. And again, multiplying top and bottom by 1 over the highest power of x in the entire problem. They should match up. I'm not going to make it too tricky there. Number 5, find the point on the hyperbola closest to the point for 0. So we're trying to minimize distance, so closest distance. So if we start off with imagining this hyperbola, we know that y is equal to 10 over x. So any point on the hyperbola is going to be x paired with y, which is also 10 over x. Getting this point on the hyperbola in terms of a single letter is very important. So use the equation in order to create that y expression, that y term that is expressed in terms of x. And the point that we're trying to get closest to is 4, 0. And the distance between points in the plane is just the distance formula there. So the distance between these points is the square root of, let's go with a little d for that. The distance between the points is the square root of x minus x squared over y, or plus y minus y squared. So x minus 4 squared, each of the x coordinates squared, plus y minus y squared, so that's going to be 10x negative 1 minus 0 squared. I'm going to end up doing a derivative at some point, so getting a negative power there's probably better than having that 10 over x structure. So again, that's just applying the distance formula as is. What we're trying to do is minimize this which means we're trying to minimize this radical. The property of radicals is that if what's inside is the smallest possible, then the radical is the smallest possible. So the next thing I would do is change this to big D equals x minus 4 squared plus 10x to the negative first squared. Notice the minus 0 is irrelevant there, so I just took that out. But again, if I can make this the smallest possible, then its square root is going to be the smallest possible. So that's easier to do and gets me the same result. So if I simplify as much as possible, x minus 4 squared is going to be x squared minus 8x plus 16. 10x negative first squared is going to be 100 x to the negative second. That's what I'm trying to minimize in terms of x. D prime is going to be 2x minus 8 minus 200 x to the negative third. At this point, I want to get that critical number. Obviously, x equals 0 is a critical number because that's division by 0. If I set this equal to 0, I'm going to first multiply by x to the third, so that gets me 2x to the fourth minus 8x to the third minus 200 equals 0. So that right there can be solved to find out answers. So if I go here, y equals 2x to the fourth minus 8x to the third minus 200. I'm going to set just a zoom 6, a standard zooming window, negative 10 to 10 in all directions. Somewhere about negative 2.5 and around 5. So I got two answers here. So if I do calc 0, left bound negative 3, right bound negative 2, guess negative 2.5. That comes out to negative 2.4886. Okay, if I test out this other one, calc 0, I'm going to do left bound 4, right bound maybe 6, and guessing 5. Looks like it's left at 5. 4.8673. So we get several critical numbers out of this. So again, 0 is a critical number, and negative 2.4886 is, and positive 4.8673 is. We're trying to find the closest, so the absolute minimum. So the easiest way to do this would be just to take this expression, which we're trying to minimize, substitute these numbers in, whichever one gives us the smallest answer is the right answer. So if I go that route, or I can even do this one here, so x squared minus 8x plus 16 plus 100 x to the negative second power. Go to my table here. I can't put 0 in, it says error, so that's not the right answer. Negative 2.4886 comes out to 58 point something. 4.8673 comes out to 4.97. That looks a lot closer. So the absolute minimum is going to be the 4.8673. That's the x coordinate. The y coordinate is 10 over x. You see here, it says find the point. We're trying to find x comma y. So x is 4.8673. And to get y, we just have to do 10 divided by that number. So 10 divided by 4.8673 comes out to 2.0545. That point lives on the hyperbola and is closest to the point 4, 0. And that's what we're looking for. Okay, number 6, a hockey team plays in an arena with a seating capacity of 36,000 spectators. With a ticket price set at $14, an average attendance at games has been 18,000. Okay, market survey indicates that every time we lower the ticket price $1, the average attendance increases by $3,000 or 3,000 people. So, imagine we charged $13, drop the price. We're going to get 3,000 more people. If we drop the price another $1, we're going to get 3,000 more people. So we're obviously getting more people, but are we necessarily getting more money? That's what we have to determine. And what we're looking for is to maximize the profit. So what we want to do is we want to create a price based on X So what we're doing is we're taking $14 and deducting $1 for every time we do it. So let's say X is the number of times we're actually deducting $1 off the ticket price. If this had said for every $2, then we'd be deducting 2, so 14 minus 2x. So as far as setting the ticket price is concerned, X is what we're looking for, how many times we're going to actually deduct the price, but the amount we're deducting goes in front of that. And the number of people are going to start at 18,000, so we can see that 14 and 18,000 original data we had, and we're adding $3,000 for every time we decrease the ticket price. So, and again, X is how many times we're decreasing the ticket price. So if we take the ticket price times the attendance, that gets us the amount of money we're making off of it. So we're going to say the profit is going to be that. Actually, that's a revenue function, but we're going to say the tickets themselves are negligible. So if we increase the revenue, we're increasing profit. So if we maximize revenue, we're in good shape. So 14 minus X times 18,000 plus 3,000X, or sorry, minus, no, that's plus 3,000X. Okay, so this is how much the ticket price is, and again, 14 minus 1x, same as 14 minus x. And this is how many spectators we're going to have, 18,000 the original, plus 3,000 for every time we deduct the dollar off the price. This is just a binomial multiplication, so 14 times 18,000 is 252,000. Outside product of 42,000x minus inside of negative 18,000x is going to be plus 24,000x. And then x times 3,000, or negative x times positive 3,000x is going to be negative 3,000x squared. It's just like that. I've got a profit function here. Now, as far as this is concerned, it's a parabola, so it's a negative lead coefficient, so which means it's going to be an upside down parabola, so it's going to have a highest point. But just considering this scenario, the most I can take off the ticket price is $14. All right? But if I took $14 off the ticket price, 14 times 3 is 56,000 people. The capacity is only 36,000. So if x equals 6, we're going to be maxed out here. So I know that the maximum x can be a 6. And as far as deducting a ticket price is concerned, or as far as adding amount, so imagine if I went up to $15, that's $1 more, right? So I'd expect 15,000 people, right? So we could actually increase the price also. That might get us more money, who knows? But if I increase the ticket price, I'll assume that we're going to lose 3,000 people. Well, I can only lose 18,000 people. So 3,000 times 6, again, 18,000. So I know that negative 6 to 6 is going to be my region that the answer is going to lie in. I also know that P prime is going to find me the critical numbers beyond the endpoints. So if I do P prime, I'm going to get 24,000 minus 6,000x. Set that equal to 0, and we're going to get 24,000 is equal to 6,000x, which means x would equal 4. So my critical numbers are negative 6, positive 6, and 4. And that's going to be, one of those is going to be the right answer. So I come over here to my y equals, maybe, there we go, and type in 252,000 plus 24,000x minus 3,000x squared. Okay. My first number, negative 6, again, we're assuming we're going to lose 3,000 for every dollar we go up. We should be getting 0 profit off of that. If we go up to positive 6, we're getting $288,000. When we did 14 times 18, it was only 252, so that's actually more money than we made with the current. So raising or lowering it to $8 is going to bring in enough customers that's going to actually increase our profit. But if we put it at $4, notice we get $300,000. So we won't have a full arena, but we'll be making the most money. That's what we're looking for. So we can see that x equals 4 results in a minimum. Now it says, how should the owners of the team set the ticket price? They're asking us what the price should be for these tickets. So once we establish x equals 4, this is the ticket price. So 14 minus 4 gives us a ticket price of $10. That's the answer I'm looking for. If it had said, what would the attendance be at the optimal ticket price, whatever, we would have had to put for there 12,000, 30,000 people be in the arena. But I'll be asking for ticket price on this question on the test. Number 7, use Newton's method to find the root of the equation x to the 6th minus 3x plus 1 equals 0 in the interval from 1 to 2, correct to 6 decimal places. So Newton's method, I'm going to let y1 be the function, x to the 6th minus 3x plus 1. Since it does equal 0 is a requirement for Newton's method, so it's already ready to go there. y2 is going to be its derivative, so 6x to the 5th minus 3. And then I simply go to my calculator, go to y equals, clear out what's already in there, type in my two functions, so x to the 6th minus 3x plus 1, and y2 is going to be the derivative 6x to the 5th minus 3. And as far as Newton's method is concerned, I can do a window real quick. They want an answer between 1 and 2. It's supposed to equal 0, so I'm going to stay from negative 10 to 10. I can get a kind of a ballpark where it's at. Looks to me like it's about 1.2 maybe, somewhere in there. So if I go to my Newton's method program, maybe, there you go. So go to program, choose Newton, and I'm going to guess 1.2. It's going to get me the answer 1.164483917. It does say correct to 6 decimal places, so 1.164484. We go ahead and round that 3 right there, up 1 because of the 9 after it. That's kind of what I expect to see. Do write this on your paper so I know what you typed in is y1 and y2. Ideally, you're going to get some answer that's appropriate. Number 8, it wants all the roots of this. So notice the equation we're trying to do here doesn't equal 0 to begin with. So the first job is to get it to equal 0. So I can either move the x to the left or the 5 cosine of x to the right. It doesn't matter as long as it equals 0. So I'm going to make it 5 cosine of x minus x. I like to put parentheses in my calculator just to kind of remind myself that's supposed to be there. Equals 0, so we're going to let y1 equal what equals 0. y2 is going to be its derivative. So cosine's derivative is negative sine, so we get negative 5 sine of x minus 1. It does say find all roots. So make sure we find all roots here. So if I begin by typing in, clear that out, 5 cosine of x minus x, making sure we're still in radians, which I am. I got negative 5 sine of x minus 1. Something I forgot to do on the last one, if you turn off the second one, because we're trying to solve the top one there. So if you turn off the second one, then you won't have to deal with the second one being graphed. As far as windows here are concerned, I don't know where the answers are, so I'm just going to zoom 6 and see anywhere it crosses the x-axis is something that matters to me. There's 1, 2, 3. Looks like 3 solutions altogether. So there's one around negative 4, one around negative 2, one around 1.3 maybe. All you need to do to the graph is get close enough that you're going to be getting to those answers. So if I now go quit and I run Newton's method again, so I got my y1 and y2 function I'm trying to solve and its derivative, and I open Newton's method and guess. If I guess negative 4, it should make the answer near at negative 4. That looks near. It says 6 decimal places, 1, 2, 3, 4, 5, 6. The next number is a 1, so it doesn't change. So first answer is negative 3.837467. The second answer, if I hit enter again, it immediately opens up Newton's method program. Negative 2 is my guess. Again, 6 decimal places, 1, 2, 3, 4, 5, 6. 7th decimal place is a 0, so it doesn't change. Negative 1.977383. Hit enter a third time, Newton's method again. We're going to guess 1.3. 1.30644400, so 7 decimal place is a 0, so it doesn't change, so 1.306440. And if it does ask for 6 and the last decimal place is a 0, put it anyway, just for effect, I think, would be better than leaving it off. So I want to see all 6 decimal places in each of those. Number 9, use Newton's method to find the absolute minimum value. So this is the same function as function 7, problem 7, but now they want the absolute minimum value. So I know f prime of x is equal to 6x to the 5th minus 3. I want to find critical numbers. Critical numbers occur at zeros, when the derivative equals 0, or when the derivative is undefined, or endpoints. No endpoints, never undefined, so equals 0 is what I'm looking for. So if I do f prime as that, f double prime is 30x to the 4th. I want to solve that. I want to do it this way. So if I go y equals, clear this out, 6x to the 5th minus 3, and 30x to the 4th. I want to find out where it occurs, so I go, I can just keep it as zoom 6, negative 10 to 10 in all directions. Looks like it's around 1, but not quite, so I would guess probably 1 for my guess. I forgot to turn the second function off. So, Newton's method, run it, guess 1, see what happens. 0.870551. Right, that's the x-coordinate. What's the actual absolute minimum value? Looking at this graph again, real quick, I'm going to turn off the second one so we're only looking at the blue one, the one that matters. We're looking for the absolute minimum value. That is our critical number. I can see all the way from negative infinity to that number, it's negative, so it's a decreasing graph. And then after that number, it's a positive, so it's an increasing. So it goes down, hits the bottom, then goes up. So I know this represents the absolute minimum just based on the graph of the derivative there. One other thing I'll mention to you, it happens to work on this one. It does say use Newton's method, obviously. But if I'm trying to solve this, 6x to the 5th equals 3. X to the 5th equals a half, so x is going to equal the 5th root of a half. You could have done it that way. 5th root, you do like this, x root, so you type in the root you want, then the x root button, and then the number you're trying to take the root of, you get the same answer. Newton's method is effective, but just know that sometimes you don't necessarily have to use that to get the answer. The last thing I need to do, though, is I want to find the absolute minimum. So this is where it occurs. That's the critical number. The actual minimum value, we have to put it back into the function itself in order to evaluate it. I don't have the function itself typed in, so I'm going to clear those out. And I'm going to type in x to the 6th minus 3x plus 1. Go to the table and type in 0.870551. And the minimum value says correct at 6 decimal places, so I have to put the cursor on top of that so I can see all those. Absolute minimum of negative 1.176376 at x equals 0.870551. That's what I'm looking for in that problem, so make sure you do go through the technique. You get a derivative. Using Newton's method, you need to take the derivative of the function you're trying to solve. So this equals 0, derivative of that. Newton's method gets you the critical number. If you have multiple critical numbers, of course, you have to find the absolute minimum. Put all the critical numbers back in there. The smallest one's the absolute minimum. Number 10, we're supposed to find f of x given its derivative. First thing I want to notice about this is I don't like the structure of this function we're trying to anti-differentiate because it's not a power function or a simple trig function. So the first thing I would do is I would rewrite f prime of x. It's multiple objects over 1, so I can put 3 over the square root of x plus x squared over the square root of x. And rather than writing square root of x, I'm going to write x to the half power because powers are better than roots. And then I'm going to rewrite this as 3x to the negative half plus x to the 3 halves. That's 4 halves minus 1 half makes 3 halves, creating this power structure that makes anti-differentiation better. That means that f of x is the antiderivative of this, so we're going to raise the power by 1, and divide by a half is the same as times 2 over 1. We're going to raise the power by 1, and divide it by 5 halves is the same as times 2/5. Plus some constant we have no idea might be there, because again, the derivative itself has a plus 0, derivative constant is 0. If I simplify this as much as I possibly can, I get f of x equals 6 square root of x plus 2x to the 5 halves over 5 plus c. Now, the second piece of information I have is what f of 4 equals. That's going to help me find out what c is. So, if I do f of 4, it's going to be 6 times the square root of 4 plus 2 times 4 to the 5 halves over 5 plus c. All right. The square root of 4 is 2. 2 times 6 is 12. The square root of 4 is 2 to the 5th power is 32 times 2 is 64. So f of 4 is equal to this expression, but f of 4 also is equal to 2. So you take this fact here, put 4 into the expression you just figured out, which has a c in it, set it equal to what f of 4 is supposed to equal. I'm going to multiply everything by 5 to get rid of the fractions. I'm going to get 60 plus 64 plus 5c is equal to 10. Move the 124 over here. 5c is equal to negative 114 divided by 5. So negative 114 fifths. So f of x becomes what we already have, which is 6 times the square root of x plus 2x to the 5 halves over 5 minus 114 fifths. Number 11. F of x, we know what f prime is, we know what f of pi is, so it's the same idea. This one's already ready to anti-differentiate. We have a constant, which is easy, we have a cosine function easy, a sine function easy. So f of x is going to be the antiderivative of 2, which is 2x. The antiderivative of 3 cosine of x, which is 3 sine of x. And since the antiderivative is not a cofunction, the sign stays the same. The antiderivative of sine is cosine of x, and since it is a cofunction, the sign changes, plus c. So f of x equals out again the plus c, because again there's always an understood plus 0. So if there was some constant in the original function we don't know about. F of pi is going to equal 2 pi plus 3 sine of pi, which is 0, plus cosine of pi, which is negative 1, plus c. And that f of pi is supposed to equal 1. 3 times 0 is 0, of course. So if I move the 1 over and the 2 pi over, I end up with c equaling 2 minus 2 pi. And I'd like to keep it as that, 2 minus 2 pi. That's an exact value for c. So that just means that this value c is supposed to go right there. So my f of x is 2x plus 3 sine of x plus cosine of x plus 2 minus 2 pi. And number 12. This time we know the second derivative. We're told what the first derivative and the function itself both equal at 0. So if I start with f prime of x, because this is just a basic polynomial structure, the antiderivative of 12x squared is 12x cubed divided by 3. The antiderivative of 6x is 6x squared divided by 2, plus some constant that we don't know yet. We beautify that up a little bit. We're going to get 4x cubed minus 3x squared plus c. I know f prime of 0 is equal to 4. F prime of 0 also equals 4 times 0 cubed minus 3 times 0 squared plus c. That's supposed to equal 4. 0 minus 0 plus c, so c is equal to 4. So this is what f prime is. We know c is 4, so we just write f prime of x then as 4x cubed minus 3x squared plus 4. Then f of x is going to equal 4x to the 4th over 4 minus 3x to the 3rd over 3 plus 4x plus some constant. I'm going to call it d, just give it a different name because c was something already. You can call it C again if you want, it doesn't matter. Once you establish what C equals, you can use C again. Just know it's not necessarily going to equal 4. If I simplify that as much as I possibly can, 4x to the 4th over 4 is x to the 4th, 3x cubed over 3 is x cubed, 4x is 4x, and then plus d can't be made any prettier. If I do f of 0, because again that's what I'm told, f of 0 is 5. 0 minus 0 plus 4 times 0 plus d, that's supposed to equal 5. 0, 0, 0, d equals 5. That means that f of x is x to the 4th minus x cubed plus 4x plus